Hello, class. This is Miss Reese from the Lamarck High School. I pray you all are staying safe and well during this unforeseen time. But today's lesson, we're going to cover the introduction to exponential functions. Now, the definition of an exponential function is a function that has a variable in the exponent position. So what does that look like, Miss Reese? Well, I'm so glad you asked. Let's say we have f of x equals a, and later we'll get into what a means, times b, and we'll talk about what b means, to the x power. So notice that the x is the exponent, which makes this an exponential function. Now, the y-intercept, y value when x is 0. So we know that the y-intercept is where the graph touches the y-axis. And if we look at this function that we have a times b to the x, the x value will be 0. And the y-intercept will be whatever a is equal to, okay? And we'll go into a few examples in a little bit. Now, the base multiplier, the product that causes the change. And the change is going to be either a growth or a decay. And that is what the b value represents. Okay, now let's take a look at this first function that they give us in the graph. It says f of x equals b to the x. Now, for your function to grow, meaning from left to right, it is growing, meaning it's going in an upward position from left to right. That means that b, whatever that number is for b, is greater than 1. So, b can be 1.5, b can be 2, b could be 100, b could be any number that's greater than 1. Therefore, your exponential function will grow. Now, what causes an exponential function to decay? Now, if b falls between 0 and 1, meaning that b is greater than 0 but less than 1, that means that your function will decay. So, some examples of a decaying function is when b is equal to 0.1, 0.25, 1/2, 3/4. All those numbers fall between 0 and 1. Now, let's go a little further into y equals a times b to the x. A is the y-intercept. So, the y-intercept is going to look like 0, comma, a. Remember, this is an ordered pair. So, for it to be in y-intercept, x has to equal 0, and whatever number a is represents the y-intercept, meaning that your graph will touch the y-axis at a. A is what we call the initial value, or the starting point. So, we start at 0, 1 on this graph, which is also the y-intercept, okay? Now, let's move over to what b means. So, b is the multiplier, or we can call b the base. And remember, if the base falls between 0 and 1, the function will decay. But if the base is greater than 1, we're going to see a growth in our function. Okay? So, B describes how the function grows or decays. So, now that we have the meaning of A and B, let's look at the domain of the function of an exponential. Now, let's look from left to right, because the domain tells us what's happening along the x-axis. Notice I have an arrow going all the way to the left, and this arrow shoots all the way to the right. So, if I'm shooting all the way to the left and all the way to the right, that means that my domain will be all real numbers. So my domain for an exponential function is all real numbers. Now, let's look at the range. The range tells us what happens along the y-axis. So let's take a look at what's happening along the y-axis. So we look from bottom to top. Now, if we look at this bottom, notice it's getting really close to the x-axis, but it never touches it. And if we go up, my arrow is shooting up, so therefore it's going to positive infinity. So the range of an exponential function will be the values where y is greater than 0. Y is not equal to 0 because remember, an exponential function is going to get really close to the x-axis, but it will never touch. So the range is y is greater than 0. Now, I said that the range will get really close to the x-axis, but it won't touch. So whenever we have a graph like that, that means that we have what we call an asymptote. And an asymptote is an imaginary line on the graph that the graph comes really close to, but it never touches it. And so, what is this axis called? You got it. This is the x-axis. So, the asymptote for an exponential function would be the x-axis, or you may see y equals 0. So the asymptote for this function would be the x-axis, or y equals 0. All right.
Now, we're going to take everything that we've learned and we're going to apply it to a couple of examples that we have, okay? So let's look at number 1. Number 1 says f of x equals 2 to the x, all right? Now, let's rewrite this because I only see one number present. Now, the number that has the exponent attached to it will always be b. But Miss Reese, where is a? Well, I'm so glad you asked. So let's rewrite this function. Whenever you don't see a number, the number is always assumed to be, you got it, 1. So a is going to be 1 times 2 to the x. Remember, anything times 1 is itself. So we know that a is 1. So all we did was make the function look different, but it has the exact value, same values, okay? Now we can find the y-intercept. And notice that the y-intercept is a, all right? Now, the y-intercept is an ordered pair. So since the y-intercept is an ordered pair, we know that the x value is correct. You got it again, 0. And a, in this case, is 1. So our y-intercept is 0, 1. Now, let's take a look at the base. The base is the big number that has the exponent attached to it. This is our base, which is correct. It's 2. Now, let's take a look at this number 2. Is this number between 0 and 1, or is this number greater than 1? Yes, this number is greater than 1. So that means that my function will grow. And if we look at the graph, notice it is growing from left to right. Now, the asymptote is going to be, you got it again, y equals 0. The domain for our function is all real numbers. And the range is y is greater than 0. Good job. Now, let's take a look at number 2. Now we have a function f of x is equal to 4 times 1/2 raised to the x power. Now, in this case, we have an a and we have a b. So we don't need to rewrite it. We just need to figure out, what does a represent, what does b represent? Well, a is the y-intercept. And in an ordered pair, x equals 0. And in this case, a is equal to 4. So that means that this graph will touch the y-axis at 4, correct. Now, let's look at the base. The base is the number that is attached to the exponent, or the exponent is attached to the base. The base in this case is 1/2. So, since the base is 1/2, does that number fall between 0 and 1, or is that number greater than 1? You got it again. That number falls between 0 and 1. So therefore, this function will decay. Now, the asymptote is y equals 0. The domain is all real numbers. And the range is y is greater than 0. All right. Now, let's look at when we have a word problem. So, it says, a student used f of x equals 8.5 times 1.025 to the x power to show how the balance in the savings account will increase over time. So, let's take a look at the function that's given. The y-intercept. You got it now, 0 and 8.5. So what does this 8.5 mean? Remember from our notes that A represents the initial value or starting point. So that means that they started their savings account with $8.50. Now, the base is 1.025. So, we ask ourselves, is this number between 0 and 1, or is it greater than 1? It's greater than 1. So, and we see that it will increase over time, so that means that my function is growing. The asymptote is at y equals 0. Our domain is all real numbers. And our range is y is greater than 0. Okay, last but not least, we have a word problem. The amount of fertilizer in a landscaping company's warehouse decreases at a rate of 2% per day. The amount of fertilizer in the warehouse was originally 65,000 cubic feet. The function f of d equals 65,000 times 0.98 raised to the x power represents the amount of fertilizer in cubic feet left after d days. So, what is our initial value? Well, they give us a few clues. Original, something is decreasing, and so our y-intercept would be what A represents, which is 65,000. Our base is 0.98. This number falls between 0 and 1, so we know that we will have a decay. The asymptote is correct. Y equals 0. Our domain is all real numbers. And our range is y is greater than 0.
All right, class, this concludes our introduction to exponential functions. I hope that you all learned a little bit about what A means. So A is the correct y-intercept. B represents what? Correct, the base. The asymptote is x-axis or y equals 0. The domain for an exponential function, correct, all real numbers. And the range is y is greater than 0. So, you all take care, stay safe, and I will talk to you guys later. Toodaloo.